Hey everybody, welcome to Sagemaker Fridays. This is an exciting episode because it's the last episode and you get to listen to me talk. So, this episode is about accelerating custom environments in the cloud. We'll talk about what custom environments means in the context of machine learning. We'll talk about containers and deep learning AMIs and deep learning frameworks and SageMaker and all the good stuff. I'm not going to give away all the juicy details right now, but let's start with introductions. I am Shashank. I'm a developer advocate at AWS focusing on machine learning, and I have my co-host here, Ram. Do you want to go ahead and introduce yourself?
Hey everyone, I'm Ram. I'm a ML architect on the SageMaker service team. I focus on primarily hosting and training models on SageMaker, and I'm excited to go through this session with you, Shashank.
That's awesome. I This is an exciting topic for me personally because oftentimes we don't talk about all the special requirements customers have. Each workload is different, each setup is different, each customer's needs are different, and we'll talk about what these are, and we'll start from the basics and start building up from there. Sound good, Ram?
Sounds awesome. Excited to understand where the entire ML journey starts here on SageMaker. So, want to see what you have in store here.
Right. Okay, so let's start with some basic definitions, I guess. So, what do I mean by custom environment? It's not like a recognizable standard term, but what I mean by that is what combination of compute, which is your CPUs and GPUs and your storage needs and your deep learning frameworks, custom proprietary algorithms that you want to bring in, what combination of all of these things, where you want to run it, is suited for you. So that's sort of a custom environment for you. And for the longest time, your favorite custom environment has been your laptop or your desktop, because why? You can completely customize it. Of course, not the hardware, but at least your development environment. But in the cloud, you have all the flexibility, right? You can customize everything. So let's start there. That's the definition of what I mean by custom environments, and we'll build it up from there. So let's start with what do you need? What do you need for a machine learning environment, right? You need access to compute. So what do I mean by compute? Your CPUs and GPUs. If you're doing deep learning, you need access to GPUs. Then you need access to storage, right? Where you store your data sets, your metadata, and all that, and checkpoints, all the things that you generate. And finally, you need access to software, and this is your deep learning frameworks. Now, if you can get these three things, you are kind of all set, right? You can set up your custom development environment. We're not yet talking about production and scaling, so that's a good point. Now, where can I get all of these, Ram, in a very simplistic way? Where can I get access to these key ingredients?
Yeah, first thing that jumps to my mind is EC2. I don't really see the problem with that because all my software tests, all my software projects, applications, EC2 is always giving me great scale. It's giving me the compute I need horizontally and vertically. So
Yeah,
I'm interested to see why we can't use that as an option for our ML applications as well.
yeah, EC2. I mean, it's probably the first or the second service that was available on AWS, right? It's been around for
Yeah.
so long. It's so many use cases and purposes for customers in machine learning and also in several other fields. So with EC2, you can get access to your CPU, GPU instances. You can get access to local storage with EBS volume up to 16 terabytes, if I'm not mistaken, and you get access to deep learning AMIs. We'll talk about that. So deep learning AMIs are these Amazon machine images, which include all the deep learning frameworks that come optimized for EC2 instances. You get access to popular frameworks like TensorFlow and PyTorch and others. If you want an AMI with just that, or if you want an AMI with multiple frameworks because you're dabbling with different projects, you get access to that. So let's start with a demo, because it makes sense to start with a demo. Take a look at what this experience looks like for a developer, and we'll build it up from there. We'll take a look at what are the benefits, shortcomings, and where should we go next. And I'll keep that suspense on. So let's switch over to our screen share. One of the most familiar UIs for a data scientist is a Jupyter notebook, right? This is where you live, you breathe, you write your code, you prototype, you test. For those of you not familiar with it, it's a great place to test out different functions, and in a non-linear way. Unlike a traditional program, you can write different cells and execute them, like shown here, right? So this interface, in my example, is running on an EC2. The server is running on an EC2 instance, and I'm accessing this from my local laptop. Now, the beauty of this setup is I can pull it up on my browser, and it's still connected to a very powerful EC2 instance on AWS. How powerful? Let's take a look, right? So I'm going to pull up a terminal here, and I'm going to run this command called NVIDIA SMI, and I basically have 4 NVIDIA V100 GPUs on this system, very powerful, and I'm able to access this from my local desktop through a browser, right? On my local laptop through a browser. You have access to all this compute power just sitting on your laptop, right? So you may even wonder, why do I need anything more than this, right? There are all these other services. Why do I need anything more than just EC2? Setting up this has a few more steps. So in order to get to this place, you need to first go launch an Amazon EC2 instance. So in the AWS console, you just search for EC2. You head over to the EC2 console. I have this one instance running. In this case, I have this for Sagemaker Fridays. This is a specific EC2 instance. It has an IP address, and I launched this with AWS Deep Learning AMI. Okay, you see here Deep Learning AMI, and Deep Learning AMI comes with all the frameworks pre-installed on it. And how do I know that? So if I go back to the terminal and say conda and list, you'll see that you can see all these frameworks pre-installed on this AMI. Okay, and these are optimized for EC2 instances, which means you just conda activate, say PyTorch or TensorFlow, and you start using it. And I highly recommend use this versus using pip installing TensorFlow or installing it from another location, because these versions of frameworks are optimized and tested and verified on EC2 instances. So in order to get access to this, you can copy the IP address here, and you have to do a couple of hoops couple of hoops you want to jump there. You can copy this IP address, and on your terminal you need to set up an SSH connection to it. And then after that, in my case, I'm using tmux to manage sessions, and then you launch the Jupyter server. So basically I have a Jupyter server here, and what this looks like, let me shut down this server and launch it again. So here you say Jupyter Lab, and now the server is running. You just want to copy this URL and paste it on your browser, and it won't work. It won't work because you also need to set up a tunnel, and a tunnel will allow you to access the EC2 instance server on the EC2 instance securely. Okay, so these are 2 steps you need to do. Couple of extra hoops, but you can get there, and you can get access to a Jupyter notebook instance here running on EC2, and you can go run your machine learning experiments. I'm going to run this notebook here, which trains a ResNet 50 model on the Cypher 10 dataset. Okay, so let's restart kernel, clear all outputs, and go run this. So this looks great, Ram. So why would anyone need anything more than this, if you ask me? Like, why would anyone need more than an EC2 instance? Right?
Yeah,
Sounds
so
like easy to use.
I mean, it seems awesome. I love being in the Jupyter Notebook environment always. It's familiar home grounds, but where I get worried is when I think of the words production, especially with ML, as you said, it's an iterative process and there's multiple steps. So here you're displaying training, but there's also inference for me to consider. And normally I'm
Right.
experimenting with multiple algorithms in some sort of pipeline step setup. And each of these different steps, right, it's very hard to just capture on EC2. So in a production setting, do I just hop back on here, get 100 data scientists on here, and have them access the same
Right.
instance, or spin up a whole instance with the same environment for all of them, and all this tunnel, different types of access and stuff?
Yeah.
That's going to be a nightmare just to give it to all of them. So I'm wondering, is there a way to really package and bring all of this together to make it simpler to reproduce, number one, and then two, also easier to collaborate, right? Because when we're talking about real-time production environments, we have teams that are collaborating.
That's true.
And I need a way
That's
to
true.
be able to reproduce these environments, these experiments, capture them, right? and make it easier for
Right, right.
especially my data scientists who are not as IT friendly as you'd say. So I'm curious to see what you have there.
Right, right. It's not really friendly, is it? The all the other hoops and steps. And I think you brought up a very good point about working in teams and scaling, because this is
Yeah,
great for a single developer, single training environment, but that's not the setup in companies or even universities where people are trying to collaborate and work together, right? In this model, one of the shortcomings is that each person gets a dedicated, powerful instance, which they're using not just for training but also for testing and prototyping and writing code. And they're wasting resources. The When you're writing code and testing, you're still paying for an entire GPU instance. So, not the best in terms of utilization. And you brought up another good point, which is like sharing. Like, I can't really go share my AMI with someone. I can share my TensorFlow or PyTorch training script. It might not work there because of version mismatch, but I can't share my environment with them. You can, but it's not the seamless, lightweight, portable way to do that. So, yeah, and there are all these other disadvantages that you mentioned, which is like hosting models. If you want to host models on EC2, you have to really consider your own security and privacy and all that, how you're going to manage that. So that's a good point. So we'll try to address each of these. While we were talking, I just finished training my model here on my EC2 instance. We just stopped at I don't know how many epochs, not too many. So just for illustration, but let's move on and talk about one aspect of it, and we'll talk about the other aspects. The first aspect for me, I think very important, is portability, right?
yeah,
How do you move your code and environments? Uh, how do you share, not just for sharing with a colleague or a friend, but also running it on production systems or other systems? What's the best way to do that? Ram, what is the uh,
one
I don't know,
word
trend?
jumps immediately. Containers. Everything in software. That's how we're shifting away from those monolithic
Right?
architectures. Why limit machine learning to that as well, right? So
Yeah,
containerization, I think, even more so than in traditional software because ML is so component based, right? I think
that's
it's
true.
crucial because, as you said, it's a dependency nightmare if you don't have containers, right?
Oh
Because
yeah,
oftentimes, like I find myself, I'm like, what version of this did they use? And then I get those cryptic
yeah.
errors. TF 2.8 does not support load tensor, some type of deprecated function that comes out of it, and I always just end up having a nightmare reproducing it. So I think containerizing your environment, as you said, that's the main thing, especially for machine learning.
Right.
New data science practitioners needs to be emphasized.
Yeah, believe it or not, when I was preparing this demo yesterday, TensorFlow 210 wasn't working for me
I believe it.
because
I believe it.
there's a mismatch with the CUDA version, and I had to go to TensorFlow 2.9 to get this demo working. There's a mismatch between the CUDA version, and it's not stuff you want to deal with, but if you can alleviate that with mechanisms like containers, I'll take it. And for a lot of you who are familiar with containers, that's great. But if you're like me a few years ago, you're like, whoa, what's a container? I don't need to use it. Isn't it for like IT ops people running infrastructure? Like, I as a machine learning practitioner or data scientist don't need to work with it. Let me try to motivate why this is important and why this can actually alleviate your pain, as we discussed. So let's go and take a look at something that Ram mentioned, which is how incredibly complex machine learning stack is. Now, when you train, you write your PyTorch script or whatnot, and you share it with a colleague or send it to another system, you expect that it just works, right? But specifically, machine learning stack is so incredibly complex because it's there's the abstraction layer where you write your code. There's the TensorFlow layer. Then there are all these libraries that TensorFlow or PyTorch depends on, and then there's CPU libraries, there's GPU libraries, and the drivers and the operating systems. And if you have proprietary tools that you introduce, there are all these different places where there can be potential mismatch and points of failure, right? How do you alleviate this, right? You can't just share your code, and you don't want to share the entire AMI. So is there like an in-between thing that you can do to alleviate this? Well, the answer is containers. We already gave you the answer, because it is so important. A container can encapsulate all the rest of the stack and make it give you a lightweight portable environment that you can share. And we'll see in a subsequent demo on how you can actually save this, extend it, and use this to run it on production. So that is sort of the benefits of using container. It really addresses that one main pain point. We discussed other pain points, scaling and all that, but we'll come to that. The main pain point of building portable environments, and containers really address that. Uh,
I
and
do have
Yeah.
one more fear there, Shashank, from my perspective, right?
Uh-huh.
Um, it's great that containers make these reproducible environments. It sounds really good hypothetically. One issue I always ran into, say I have to build my own containers, you're saying bring my own Docker image. I know Docker's one of the main container tools out there. But
Right.
when I have to build these images, I'm pip installing everything, like TensorFlow, or
Right.
actually PyTorch is a better example here because I have PyTorch and TorchServe, right, for hosting my models. And then
Yeah.
so many times it craps out because there's some sort of dependency error. They're like, TorchServe does not support this version of PyTorch. And by the end of
Right.
it, I have this huge requirements.txt file that just I
Yeah.
have no idea of, like dependencies that I've never heard of, and I'm just randomly typing different versions, hoping it works, and installing
Right.
that in my Docker file, like manually with pip install. So like, I'm wondering, is there any way to like simplify that process? Because for me, um, just building from ground up, especially with, as you said, such
Right.
complicated stacks, especially when it comes to GPU, I just have a nightmare. Like I've been shying away from GPUs because I get scared of like some sort of dependency driver, and
That's
especially
true.
NVIDIA,
Yeah.
that gives me nightmares sometimes getting everything working together. So I'm just wondering,
Yeah.
is there a way to get all these frameworks like automated faster and for us to just add what we need on top of it?
Yeah, I'll give out the answer, and then I'll say why. Um, Deep learning containers, AWS deep learning containers, just like how you have the deep learning AMIs that have all these frameworks built in. I showed you deep learning containers, and I'll quickly pull up the page with the list of containers that are available as starting points. So regardless of what kind of work you're doing, depending on which framework you're using, whether you're using PyTorch or TensorFlow for training or model hosting with CPU support or GPU support, which version of Python, where you want to use. So the benefit of these images are that they're a good starting point, and I'll share why, because for a lot of you listening, this is sort of not familiar grounds, right? The Ram mentioned building. So this white box here and sound by red box right now is your containerized environment. But if you want to build from scratch, which means if you want to start building from here, you have to start adding all these different libraries, and that's potentially issue for you too. But what if you could get all of this? What if you get all of this ready to use, so you can only focus on adding your code on top. So you just focus on adding your code on top, and that's what deep learning containers do for you. So that's what these specific containers images do for you. If you're working with, say, PyTorch 1.12 and you want for training CPU, just go copy this. And if you're not familiar with Docker, Docker is arguably the most used tool and one of the most friendliest tools to work with containers. So you say Docker pull a specific image, and you have an environment that has these frameworks. The follow-up question was, how do we actually do that? And what do you know? We have an example, right? We should have an example. It's not really that complicated. So if you go to our container page, there's the first step is to log into the ECR repository, and you run this code to log in. Now, what is ECR, right? I'm not going to throw jargons at you. Well, let's unpack this. Think of containers as unit of software. So this is your framework and all the dependencies. And a container registry is where you save the software, right? It's a repository. You can like an app store, if you like, you can save your apps there, right? So you're logging into AWS has an repository here which contains all these containers I showed here. Now, first thing you want to do is like log into that repository as I showed here. And once you log in, you get a login succeeded, and then you can pull the container to your system. So you all you have to do is like copy paste one of these things, If you want to pull a TensorFlow or Python, let's say you want to pull this specific container image, I go paste that here, and make sure I choose the correct region. So this is, I'm in US West region, so I say West, US West 2, and that looks good, and I execute that code. And what Docker does is pulls all the different layers of the containers, and once it is finished running, I'm going to stop this because I don't need this specific container for the rest of the demos. But you can do Docker images, and you can take a look at, you can of course also do this on the terminal. Just say Docker images, and you can see all these different container images that are available on my EC2 system here, but you can pull it from wherever you want. So, okay, so that is how to pull your container. How do I extend it, right? Again, I'm glad you asked. I know you're asking these questions because I can hear you, but here's here's how you pull, build, and extend a container, right? So containers require you to specify instructions in a file called Docker file. Oftentimes, most ML practitioners don't need to do this. Okay, you don't need to. In fact, if you sit till the end of this presentation, because it's so exciting, you will learn that you can do away without, you can do all of this work without even specifying containers. Just bring in your training script and frameworks. But this is what happens behind the scenes, and this is what would happen if you were to use it with EKS or Kubernetes, for example, right? So a Docker file is something you would use to extend containers. With specifically if you have proprietary code, right? You start from one of our base container images I showed you. Then you can add your proprietary code here, your code, right? Or your code or your framework. Let's say you have proprietary frameworks within your organizations, right? You can add that information here that builds on top of. To Ram's point, you don't have to start from Ubuntu and start installing TensorFlow and all that. You start from this and then copy. In this case, it's just copying training scripts into the container image and building a new container image. And I have examples here for, this is for CPU and this is for GPU. You start with a different container here. See, you see GPU here with CUDA. So you start with a different container image if you're using GPU, and you start with a different container image if you're using CPU, and they're all listed on the page I showed you, and we'll share these resources with you at the end of the talk. So I'm gonna close it. Okay, so those are the Docker files that you write. Maybe you're gonna write it, or maybe there's someone in the company that's gonna write it. After you do that, you remember I said a container repository is your app store. Yeah, you want to push your custom containers into those. So let's search for ECR in the console, which stands for Elastic Container Registry. And in the container registry, you can set up private repositories here to which you can push your images to. And that's exactly what I'm doing in this notebook. So I have this repository named custom DL containers. In my case, I already created it. It already exists here, custom DL container. This is where I'm pushing all my custom container images to. So I can, to do that, I can specify the repository. So in this case, I'm going to create a repository, but I've already created, so I don't need to. I'm still going to run it. It'll say repository already exists, so you don't need to create it. And then you can build your Docker files. And this is Docker build. I'm basically running terminal commands in Jupyter Notebook. You can run this in the terminal, and then you can push your container images into that repository. And when you do that, you're going to see it appear here. Okay, so this is, now why did we do all of this, right? Now if you're in a company that uses, say, PyTorch with a custom extension, you build a container, push it to ECR, and the rest of your team or organization uses that as a starting point, not the upstream framework, right? They use your custom. So this is the this is the URI you share with all of them, and they're going to be using that for their work. Okay, we spoke a lot there. I'm going to take a pause here, Ram. If you wanna, I don't know if I rush through something. If you want to unpack it a little bit, or just recap what I said, so that you know I didn't speak too fast or anything.
No, understand fully. So at the base, these DLCs, they can be used in any environment wherever you're working, and you can containerize and bring your code onto them and add any other dependencies that you have. But these take care of a lot of the heavy lifting, as you said. And from what I understand, you can use it for training and inference both, which is awesome. And CPU and
Yeah,
GPU covered as well. So it's great that you don't really have to worry about a lot of those nitty-gritty installations there, and especially the core ones,
right.
right? And you can focus on pointing to the right code directory or pointing to smaller packages that you might be adding on. But this also brings me to a point. So how do we scale this? We have a container, right? Do we
Yeah.
scale it on EC2? Do we scale it on, do we have a
Where
container
we
for
run it,
training and inference?
right?
Like, where do we run it and how do we orchestrate it? That's the word I'm looking for. How do we
Yeah,
like, I'd assume it's not very different from EC2 if we just have everything on one container, right? If I had both my training, inference, and experimentation and everything on EC2, my logic then would be,
right,
why don't we just have one instance and not deal with any of this container work? So how
right.
do we orchestrate these different moving parts? How do we make sure it's like a flow that we can manage and give the right amount of compute to each, right? Because when I think about cost savings, this doesn't seem
Mm.
very different from EC2 yet to me. Because EC2, as you said, is
Yeah,
persistent, up and running, your build as long as you're using it. How is this any
right.
different, and how can we better utilize our resources here? And I'm curious
Yeah.
to hear about.
No, that's a very good point because EC2 is where you run software and a container is software and you run software on EC2, right? Uh, that sounds logical. But if you want to run this on multiple EC2 systems and then you starting to think, should I just go launch a container in each EC2 instance? Doable, but what if it runs into tens or hundreds, right? And who's going to manage all of that? So here's the analogy I really like. When you launch, say, your favorite browser, say let's say Firefox, and you're opening tabs, are you telling Firefox which CPU core to run each process on? No, right? We're not telling Firefox to do that. Who does that work? Who does that work of assigning? The operating system. So operating system is taking the workload from Firefox and deciding how to run it on the processor. Now let's extend that analogy to the cloud and cluster. So when you have a bunch of EC2 systems and you just want to run a container for serving a model or for training on large number of EC2 instances, who's going to do that work for you? We need an operating system, right? And that layer is called an orchestration system. And use the right word, orchestration, because someone needs to orchestrate this workload on a cluster. And to put this into perspective, let's take a look at this image here in the slide so that it we can build it up. So we already spoke about EC2, which is where your stuff runs, right? It's a fundamental service. We spoke about containers and where you store them. So you store them in ECR, which is a container registry. So you have where you run and where you store them, and who's going to do the rest of it, right? This is where you have orchestration systems, and you may have heard of words like Amazon ECS, Elastic Container Service, or EKS, Elastic Kubernetes Service. These tools are kind of like analogous to our operating system, where they say you just tell them, please take this container and run this, and it'll say, I'll go find the right EC2 instance for you and run it for you. You don't have to tell me you need to run it on the first one and the fourth one, right? So
Yeah.
that's an orchestration system. And arguably the most popular one you've heard of is Kubernetes. Let's take a look at what that looks like. And beware, Kubernetes is not for the light of heart. It's which is why I'm not recommending that you use this, right? I'm showing uh, how Kubernetes does this, but in a lot of organizations you either are using another layer of abstraction, which is Sagemaker will come to, or you have IT teams or operations teams within your organization that manage the Kubernetes for you, and
Yeah.
then they provide another layer of abstraction like Kubeflow, manage Kubeflow, and we'll just touch upon these things. So to quickly go through what this looks like, and I won't be running this demo, but I'll be showing you how to do this. So you can launch a Kubernetes cluster. Launching is very easy. With a single line of command, you can launch a cluster. The challenge is actually maintaining it and running it, which is why you need someone who's experienced in Kubernetes. So submitting a job to Kubernetes looks something like this. So it follows a model called a declarative model. So you specify what you want to run and the state at which the Kubernetes cluster needs to be, and the orchestration system, the scheduler, makes sure it runs there. So you don't want to be writing this as a data scientist, but if you ever do, you have to write a specification file, specify a job, and specify the container image. So you may remember this is the same type of container, custom container we push to ECR in our code, right? And then you run this job with the kubectl command line, kubectl apply, and then you apply, and Kubernetes is going to run this. Again, not many of you are going to do this, but you're going to be using an abstraction layer like Kubeflow on top of it. Okay, so Kubeflow is an ML specific abstraction layer that sits on top of Kubernetes. And again, you as an ML practitioner may not be using this, but if you have teams, if your company is standardized on Kubernetes, then you could use Kubeflow on AWS to give you all the machine learning features like notebooks, servers, and hyperparameter tuning and all that. So that's all part of Kubeflow. Again, I won't spend too much time into it, but because we are all ML practitioners here, we are not really IT ops folks who find that material more familiar. So it seems like Ram, Kubernetes addresses those challenges, those scaling, but it's
Yeah,
not really the right tool for me and you, right?
yeah, I think
Is there a
you could tell by my
I think
face when I was seeing
the
the
answer.
YAML files and all. So I like that it does, like you said, it is cluster and you can distribute the components, right? It gives me an idea of the
Right,
flow. But I don't like the fact that I have to define it as training. I have to define it as hosting. Because for me, for IT/software, it makes sense. That's how we've designed and
right.
defined everything always, right? But it doesn't seem very ML specific. I want something that comes in and says, this is
Yeah,
your training component, give me your code. This is your hosting component, give me your code. And I feel like that's a true like data
right.
scientist experience. So let's move on to
Yeah,
that point. I'm curious to see
yeah,
if we have something that will be able to solve that problem for me.
right. Historically, I think the most successful software have been the ones that have understood the audience very well, right? Not that it's capable or functional, but understood the audience and had the right UIs, interfaces, right? Some very good mature software won't take off because it's not meant for the audience. And Kubernetes is not meant for a data scientist. A data scientist will not know what to deal with it unless they also come from that background. It's just complicated because setting up a cluster is one thing. How do you patch security issues? How do you maintain the cluster over time? And how do you manage all those worker nodes and scaling policies and all? It's just too much work, too much complications. And if you go back to our layer cake here, right? So I already mentioned there's this abstraction layer. Can you add another abstraction layer which is for data scientists? And that's where SageMaker comes into play, where SageMaker offers another layer of abstraction on top of the fundamental compute here, which is EC2, which simplifies for a data scientist how they interact with the cluster. So it's really truly how an app runs on a system and doesn't really operating system takes away um, all that specifications. So that's the thing SageMaker is going to do for you, and I think this will become clear once we take a look at an example here. So many of you are familiar with SageMaker. If you're not, it's a suite of services. It's not just one service for everything from data processing, data labeling, feature stores. There is distributed training. There's spot instance, managed spot training support, which save costs. There's model hosting, model monitoring. There's debugging. There's a lot more. I'm not going to remember everything, and we keep adding new features. I'm barely trying to keep up. It's basically an automation and pipeline management. That's amazing. Like you can automate all of these things. So that's SageMaker. In this demo, though, I'm going to focus on model training and leveraging a cluster to train your model. So there are two ways to do that on SageMaker. Let's go through this image here, and it'll become clear. So as a data scientist, you can bring in just your training script. So all you need to do is bring in your training script. Say you're working with TensorFlow, and you have a training script here. Let's take a look at this. So I have a training script called TensorFlow Cypher10 tf2.py. Okay, this is a training script that you would write just like you would write on your local machine, right? So it has all the basic steps like processing data, and then your training loop, your hyperparameters, and your training loop. So you bring in your training script, you make some minor changes so that it can accept hyperparameters as command line arguments, because SageMaker is going to share those to your script from when it runs the job. And you write up an estimator function where you specify where your training script is, what kind of GPU or CPU instance you want to run it on, how many you want to run it on, 1 2 4, what version of Python and framework version, and call estimator fit, and it's going to do all of that for you. So behind the scenes, it's going to take your code, pull a container from ECR, and this could be one of the containers that are here that we spoke about here. Depending on which version of TensorFlow, whether it's CPU or GPU, SageMaker will go figure out the right one, pull it for you, download your code, provision a cluster, copy your dataset from Amazon S3, training, upload the metadata and all the training results, model back to S3. All of this happens behind the scenes for you. That's the nice thing about higher level abstraction. And the last thing I'll mention is, by decoupling where you write code and where you train with SageMaker, you only pay or end up paying for the duration of training, not for all the time you spend prototyping and writing code. If you take a look at this, you may spend 5 hours developing some code to do something on your maybe even a CPU based EC2 instance, okay, or a SageMaker notebook instance. But then you want to train only once the code is ready, and only then you use GPU instances, and you're only built for that duration of training on the GPU instance. Contrast with the first setup, I'm running a GPU instance on EC2. I'm running it all the time, so I'm paying for it throughout the time. So I really like this decoupling of training, and the workflow is very similar if you use custom containers. If you build your own custom container like what we did, pull up a deep learning container, add in your proprietary code, and then push it to ECR. SageMaker will pull that container instead of one of the ones to resolve one of the container it resolves from the framework. And how it does that is, you specify the image location, and you just provide it to the estimator with the image location here. Simple. So this is the TF. I'm sorry. This is the custom DL container. This is my registry, and SMGPU is the tag. So if you go back here, this is the repository we're talking about: custom DL containers and SMGPU. So basically, this copy URI, right? This basically is the location of the image, and SageMaker is going to do the same thing here: run training and um, bill you only for the duration of using GPUs. So again, I'll pause here. Just to summarize, another layer of abstraction that really is designed for data scientists and ML practitioners, and works with any custom container environment you bring. And you can orchestrate these trainings from anywhere. You can use SageMaker notebook instance, SageMaker Studio notebooks, or from EC2 or from your own laptop. You can orchestrate and use a SageMaker services from anywhere. Seems like that hits on all the challenges from the earlier ones, right, Ram?
No, definitely. And as you said, EC2 EKS, if you want greater, any of these options work, depending on the
Right,
resources that you have, depending on the route that you want to go. EC2 EKS, if you have the flexibility and freedom to
right,
be able to build from scratch up, they seem like great options. SageMaker, like you said, it's a managed offering and has a suite of services for each of the steps of machine learning, and it's
right.
tailored. So seems really great in that sense.
Yeah, Ram, I know we were discussing this before, and something you mentioned that really made me think about why this is so important to have this layer of abstraction, right? Um, uh, the important it's the need to scale is getting more and more because we're seeing like these model sizes getting bigger and bigger, right? And you're seeing this with your use cases too, right?
Definitely, especially one of the models we're talking about, LLM models in specific, right? These NLP
Yeah, the
models,
large,
just the corpus of data we have to work with, and even the
right,
size of the models nowadays. If you look at GPT-3, everything that's out there, it's just the scale is ridiculous. And one of the most important things is any model is only as good as the data it's trained on. So ensuring that
right,
we can match that skill in training, one, and then two, also hosting. Because at the end of the day,
right,
machine learning is recognized in hosting and inference, right? And if we're not able to scale up to reach like thousands of invocations per second,
right,
high throughput at low latency, those two matter a lot to me in terms of these compute offerings. And in
right,
general, I see that all three of these features can bring that. Once again,
right.
depending on how you utilize them, but properly configuring them as well.
Yeah, that's such a good point. The need for compute is going higher, and if you're going to be struggling with managing, I mean, if you have the expertise and the inclination to do it, you can manage a fleet of EC2 instances and do it yourself. But for the everyday ML practitioner, training a large language model is so much more simpler with an abstraction like SageMaker versus actually managing all the infrastructure yourself. And another reason I really like the ease of scaling is when you're doing the prototyping and learning phase, you want to try different hyperparameters, you want to try different like subset of data sets and all that, and you can do that sequentially on your machine, easy to instance. But then uh, you're gonna pay the same if you do that in parallel, right? So if you can do it one by one and run 10 experiments, each experiment takes an hour sequentially for 10 hours, or you can do it all in 1 hour. And as far as how much you pay, you just pay for 1 hour times 10, right? Whether you do it sequentially and parallel. And
Mhm.
SageMaker, like you can put a loop around this fit function, right? Just switch
Yeah.
out the hyperparameters here. That's the beauty of doing this. Like you can switch out the hyperparameter, create sets of these hyperparameters here. And I have an example of this. I'll share. You can go through these fit functions in a loop, and you can run them in parallel. So parallel experimentation and those large models where you don't want to manage infrastructure. In fact, SageMaker has managed model parallel and data parallel libraries
Yeah.
too, right?
Awesome.
That makes it really simple. Uh, okay, I think you did a nice recap talking about like self-managed and fully managed, and
Yep.
like EKS something in between. Is there things that we didn't cover that
Yeah.
let's say a small organization or a data scientist would care about, whether it is custom
Mhm.
environments or other tools?
Yeah, one tool that really stood out to me in particular, and this is going back to my roots as a learner, as much of us are. Um, I need a place sometimes just to experiment if I'm learning something new or trying something new, just as a data scientist, right? Forget the cloud,
Right,
forget SageMaker, forget EC2, forget EKS. I just want to be able to run my Jupyter notebooks, and I want compute power available for that. Because if I run on my local machine, I learned the hard way, it normally blows up
right,
when I'm playing around with stuff of that sort. And I really liked SageMaker Studio Lab. It was a free offering, and on that, I was able to experiment, and I've actively been using it just to pretty much
mm,
play around with machine learning. I love ML at the end of the day, trying out new models, trying out new problems there, and it's been a great experience for me just to give me that compute power that I need to be able to learn
right.
and just more importantly, just practice as I want before even thinking about companies or projects or anything of that sort.
Yeah, I just brought it up on the browser because I like it too. Just like you, it's SageMaker Studio Lab is free for many of you don't know. You can get 12 hours of CPU time or two two times 4 hours of GPU time. You get a proper GPU for free, right? You can, I mean, once you launch, you get access to a Jupyter hosted Jupyter notebook environment. Let's try the CPU instance. You get hosted Jupyter Notebook environment, which you can use to actually prototype and test and all that. So Studio Lab is awesome. If you don't have access to it, you can request for a free account, and you should do it because it's free. Why not? And whenever you're ready to scale or run large scale models, you can always switch over to Sagemaker, or you can use Studio Lab to prototype and then offload your training to Sagemaker services. So I just launched my Studio Lab notebook. So this is basically again your hosted Jupyter notebook environment in the cloud that you can use for your your education, your prototyping, your MOOCs that you want to do, and all that. So it's a great environment. Glad you mentioned that, Ram. Okay, so I think we are ready to close now. I don't know, any final parting thoughts, uh, any final summaries from you, Ram?
No, I mean, I love the suite of services that we have for machine learning out there. Excited to
Something for
learn
everyone,
more.
right?
Something for everyone to try out, right? And
That's
whatever
true,
fits your use case best, feel free to always reach out to me and Shashank with any
right?
questions. You could always follow up and make sure we can get you up and running on whatever suits your project's needs. And thank you, Shashank, for conducting such a great session. It was super
Oh,
informative for me.
thanks. Thanks, Ram. I enjoyed doing this, and thanks everyone for taking your time to attend this session. This is the last session of the season, so it's a special one for us, definitely. Hope you enjoyed the season and also this specific episode, and be in touch. And we'll see you in future seasons of SageMaker Fridays. Uh, Me, Shashank, signing off.
Thank you.
Bye.